And the dot product is just a way for us to multiply vectors together. So we've multiplied vectors by a scalar, but we've never multiplied them together. So what we're going to do today is use the dot product. That's going to help us find the angle between two vectors, and then we're going to find the work done on an object. So the first thing we have to look at is the definition of the dot product. Okay, so it's really custom for us to, when we see these boxes, we just kind of glaze over them. We don't really think about what's happening here. The dot in the dot product is going to look like the multiplication. And then remember, this is all going to be in bold because they are vectors. Okay, so we're going to try to write this in our own words about what's happening. So what's happening here? What would I say? This A1, A2, what is that? Okay, so you're multiplying. What are you multiplying together? Well, what do the A's represent? The horizontal component, right? Okay, so this is the product of the horizontal component. This is the product of what? The vertical component, and then we're adding them together. Okay, so one way we can think of this, it is the sum of the products of the horizontal component and the vertical component. Okay, when we try to write that in our own words, then that starts to make sense to us. Okay, then we aren't just seeing variables with little numbers by them. Now we're putting meaning behind that formula. Okay, and then we can apply it. The next formula that we're going to use today is the angle between two vectors. So the angle between two vectors is going to be the cosine of theta equals u dot v, and that is the dot product. And then remember what the absolute value means. If you have the absolute value, that means you're calculating what? If you see that symbol. The magnitude, okay? So then I put that as the product of the magnitudes. So when we're trying to solve this for theta, we're going to have to use the inverse cosine, okay? And then we're going to be doing the inverse cosine of the dot product divided by the product of the magnitudes, okay, of two vectors. Now, we also have properties of the dot product. And these are ones that you are familiar with from multiplying and addition. So it is commutative, which means you could do u dot product v or v dot product u. It is associative. So if you had a scalar multiple a, it doesn't matter if you do the a times the u and then do the dot product with v, or if you do the dot product first and then multiply by the scalar, or if you multiply the scalar by v and then do the dot product with u. So it is associative. And then the last one is distributive. Okay, so you could distribute the w to both the u and the v, and then you would do the addition of those two dot products. Okay, the last one, you're really not going to use that much. But you do have the magnitude squared, which would be the same thing as the dot product of u and itself. Think about how that works, because when you're doing the magnitude, what's involved in finding the magnitude? How do you find the magnitude? What is the formula for the magnitude? Okay, yeah, so the square root of a squared plus b squared. So really, when you're doing the square root, if you're squaring it, what's going to happen? Those are going to undo each other, yeah. And you'll have your a squared and your b squared. Okay, so for example 1, we are going to find the dot product and the angle between it to the nearest degree. Did you guys already write down this part or no? Okay. Here, we'll do this here. Okay, so the first thing you're going to do is find the dot product, and then you're going to find the angle between u and v to the nearest degree. Okay, I'm going to write this in pen. So your first vector u is 3, negative 5. And then your vector v is 1, 4. Okay, and I'm going to help you with this one since this is your first time doing it. Okay, so the dot product of u and v, remember we don't write in bold, which is why we're going to be using the vector symbols here, is a1 times a2 plus b1 times b2. Okay, so here's my a1. And then here's my a2. And then my b1 times my b2. Okay, so then I'll end up with 3 minus 20, which will give me negative 17. Okay, that is my dot product. Okay, then for step 2, to find the angle in between those two vectors, I'm going to do the cosine of theta equals the dot product over the product of the magnitudes. So the dot product has already been found. We just did that in the first step, negative 17. Okay, what I'm going to do is find the magnitude of u, which is the square root of a squared plus b squared. Okay, so 3 squared plus negative 5 squared, which is 9 plus 25, root 34. Okay, and then I'm going to find the magnitude for v. Okay, so that would be 1 squared plus 4 squared, or 1 plus 16, which is the square root of 17. Okay, so what you have is the cosine of theta equals negative 17 over root 34 times root 17. So to find theta, you're going to do the cosine inverse of negative 17 over root 34 times root 17. Okay, you have to make sure that your calculator is in degree mode. Remember that when you reset your calculator, which is what you do for every test or quiz, okay, you automatically, I'll show you, look, second plus 712. You automatically get put back to radian. Okay, so you can't set up your calculator before your quiz and then just think, oh, it's good to go. Once you clear that, you have to go back in again and you have to change it to degree. So I'm going to do the cosine inverse. I'm going to show you how I'm entering it in here. This is negative 17 divided by, and then I'm going to put the bottom in parentheses. My calculator is older, so it's going to have more parentheses than some of yours, times the square root of 17. If you do get a domain error, it's because you have most likely not put that in your calculator correctly. Okay, so that's why it's important for you to do this and not just watch me do it. Okay, and then you get 135 degrees. Okay, and that is your angle between the two. Now, what I want you to do is part B. So I'm going to give you your two vectors. And while you guys are working on part B, I'm just going to graph just to show you how you can identify that angle in between. Okay, you don't have to graph it, I'm just going to do it to show you. Okay, so what I want you working on right now is part B. Okay, and then if you get done with part B, then just quietly check with your elbow partner. it sounds like some of you are finishing up. So again, I just wanted to show you this visual representation. For part A, this is your vector 1, 4, and this is your vector 3, negative 5. And I just started them both at the origin. So you can see by looking at this angle, it's definitely going to be greater than 90, right? Because this would be like your 90-degree angle here, and we know that it's past it. Okay, so 135 does seem like something reasonable. Now for B, does this look greater than 90 or less than 90? Okay, it definitely looks less than 90. It is an acute angle. Okay, so for step 1, for part B, when you did the dot product, you should have done 4 times 6 plus 1 times negative 5, and 24 minus 5 will be 19. Okay, that's for step 1. For step 2, you're doing the cosine of theta equals, and then 19 is on top. Okay, and then for U, when you find the magnitude, it's the square root of 4 squared plus 1 squared, so it's root 17. And then for V, it's the square root of 6 squared, which is 36, plus 25, which is going to be the square root of 61. So then when you're finding theta, you're doing the cosine inverse of 19 over root 17 times root 61. Okay, now notice that in the directions, it says to round to what? It says to round to the nearest degree. Okay, so when you did this, you got approximately 53.8 degrees, which is going to round to 54. Okay, so double check and make sure you follow the directions and that you round to the nearest degree. Okay, and yep, it was an acute angle here. Questions for me on example 1? All right, another way we can use the dot product with vectors is to determine if 2 vectors are perpendicular. Okay, now remember, if you have 2 lines or vectors that are perpendicular, what happens? What does that mean? Okay, yeah, they're going to meet at 90-degree angles, okay, if they're perpendicular. So we know that 2 non-zero vectors are perpendicular if and only if their dot product is equal to 0. Okay, so this is their dot product is equal to 0. Okay, now I asked you to think about why does the dot product have to be 0? Okay, and we'll start this off by saying the dot product must be 0 because, and now we can think about this. Yeah, you think you don't?
Because cosine at 0 value is the vertical up and down.
Okay, so if your dot product was 0, right, then you'd have the cosine of theta equals 0 over the magnitude, right? If your dot product was 0, 0 would be on top. And 0 divided by anything is what? 0. So if you have the cosine of theta equals 0, think about where your cosine is going to be 0. Right? This is 0, 1, which is going to form a 90-degree angle. And we know that if they're perpendicular, they're going to form 90-degree angles. Okay? So the dot product must be 0 because to be perpendicular, there must be a 90-degree angle and since the cosine of theta would equal 0, theta would equal 90 degrees. Okay, so I'm going to give you a set of vectors, and then I want you to determine if they're perpendicular. So to determine if they're perpendicular, what is going to be your process? What are you going to do? Yeah, so first you have to find the dot product. And then B, your U value is 3I plus 4J. And your V is negative 3I plus 4J. Okay, so first you have to find your dot product. And then, Henry, how do you know if they're perpendicular? If you could do it that way, but what's their dot product going to be? Yeah, so if your dot product is 0, then you'll know that right away. So you wouldn't even have to use the angles, because you know that if the dot product's 0, it will produce that 90-degree angle. Let them do it. Okay, so for the first one, you did get 0 as the dot product. Okay, so that means yes, they are perpendicular. Okay, and then for the second one, are you guys already done with that one? Right, remember when you do the dot product, even if you have I and J, you are not taking your I and J. Because I is just saying that this is the horizontal component, J is saying this is the vertical component. Okay, so you're not taking I and J, that's just your other form. So for this one, you have 3 times negative 3 plus 4 times 4, which will be negative 9 plus 16, which is definitely not 0. It will be 7. Okay, so then we know that these are not perpendicular. Alright, and then let's go to the next side. Okay, so what we have to do for example 3 is find V, the dot product of V and U plus W, and then they give values for U, V, and W, and I said hint to follow the order of operations. Okay, there's actually more than one way you can do this. So when I start this problem, I actually prefer my vectors in component form. So what I would do is I would just rewrite this as 2, 1, and this would be 1, negative 3, and then this would be 3, 4. So if I'm going to follow the order of operations, then what I'm going to do first is what's inside the parentheses. Okay, so I'm going to do the U plus the W. Okay, and I'm really just adding those two together. So you have 2, 1 plus 3, 4, which is going to give you 5, 5. Okay, now I'm going to plug that back in, and I'm doing the dot product of V with 5, 5. Okay, because that's your U plus W. Actually, I'll write it as U plus W. Okay, so then your vector V is 1, negative 3, and that'll be the dot product with 5, 5. Okay, so then you have 1 times 5 plus negative 3 times 5, which will be 5 minus 15, which will give you negative 10. Right? What's another way that you could do that?
Distribute first.
Yeah, yep. Okay, or you could use the distributive property. Okay, if you use the distributive property, then you would have the dot product of V and U plus the dot product of V and W. Okay, so we're going to do that both ways. See which way we like better. And U was 2, 1 plus V, which was 1, negative 3, and W, which is 3, 4. Okay, so we're just going to do the dot product twice here. So 1 times 2 plus negative 3 times 1, which is going to be 2 minus 3, or negative 1, plus 1 times 3 plus negative 3 times 4, which will be 3 minus 12, or negative 9. Negative 1 plus negative 9 is going to be negative 10. Okay, so either method is going to produce the same result. Okay, so you can choose which one you want to do. All right, then the next thing we're going to talk about is work. Work, 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 work. Okay, so one practical use of the dot product is to calculate work. So in everyday use, you think of work as the total amount of effort required to perform a task. Okay? In physics, the work has a technical meaning, but it conforms to that intuitive meaning. So we do have a formula. If you have a constant force of magnitude, so this constant force of magnitude we call F, that's going to move an object through a distance D along a straight line, then the work done is given by this formula. Okay, so the work would equal F times D, or the dot product. Okay, so what this means is the work equals the dot product of the force and the distance. Okay, so we calculate the dot product. Alright, so let's look at our first example. For example 4, we have a force that's given by the vector F, which is at 7, 6. So we already have our force vector. It's going to move an object from the point 2, 1 to the point 5, 6, and then we have to find the work. Okay, so in order to find the work, we need the force vector and we need the distance vector. We already have the force vector is 7, 6. What we have to do is find the distance. Well, if you're given 2 points, how can you find the distance? That? Yeah, you can. Or you can also just subtract. So treat this is your initial point P, and this is your terminal point Q, and that's going to give you your vector. Because you do want that as a vector. The distance formula is going to give you the length of the line. This is going to give you your direction, okay, in vector form. So to find the work, we're going to use P, which is 2, 1, and then Q, which is 5, 6. Okay, so remember to find a vector using the initial point and the terminal point. you're just doing x2 minus x1, and then y2 minus y1. Okay, and that's going to give you your vector. Okay, so P is your initial point, Q is your terminal point. So this is your x1, y1, this is your x2, y2. Okay, so your x2 is 5 minus 2, y2 is 6 minus 1. So then your vector is 3, 5. Okay, so then what we're going to do is substitute that into our formula. All right, and then now we can do the dot product. So 7 times 3 plus 6 times 5 is 21 plus 30, which is going to be 51. Okay, so that is the work that is done. Now, this doesn't give you any specific units, so you can just say 51. When we get into the next example, you're going to say there are units on it, so we will go ahead and label those. Okay, questions for me on example 4? Okay, so we have a man who's pulling a wagon horizontally, exerting a force of 30 pounds on the handle. If the handle makes an angle of 70 degrees with the horizontal, find the work done in moving the wagon 200 feet. Alright, so first we're going to draw a practical picture, and then we're going to put the picture on our coordinate grid. I don't know about you guys, but when I was little, I loved my wagon. It's a little radio flyer, so that's what we're going to have here today. Mine had these on it.
The little sides.
The little sides, yeah.
It's called the radio flyer.
Yeah. Okay, so the force that's on the handle is the 30 pounds. And then that's going to make an angle of 70 degrees with the horizontal. But he's pulling it. Okay, now what we're going to do here is we're going to put this on the coordinate grid. So remember that your distance is going to have to be on a straight line. Okay, so we're going to draw this on our grid. Okay, so this is going to be 70 degrees. Okay, so here's my 30 pounds. This is my force vector. Okay, here's my angle, which is 70 degrees. Okay, and then my distance, I want to think of as coordinates. Okay, so here's P, here's Q. Now, when you're doing the coordinates, I always start at 0, 0, just because I think that's the simplest. Because if you're moving 200 feet, what would this coordinate point be? Pay attention, please. Henrik, Colin, are you with me? Okay, so then this would represent your 200 feet. Okay, so when you're writing these as vectors, this is going to be your distance vector. This is going to be your force vector. For the distance, you can actually just look at it and you'd be able to tell me what that vector is, because it's not going anywhere up or down vertically. It's only going horizontal, and in what direction? To the right. So that means it would be positive 200, 0. You can also think of it as subtraction. right? 200 minus 0, 0 minus 0. But like I said, you can just look at it and see I'm going 200 to the right. I'm not going up anywhere, so this is going to be my distance vector. Okay, so they both have to be vectors. Your force, think of this as the magnitude times the cosine of theta. So your magnitude is your force. So if you're exerting the force of 30 pounds, this is going to be 30 times the cosine of 70 degrees, and then 30 times the sine of 70 degrees. All right, so then when we calculate that, we're going to just round it to the nearest hundredth. So this will give you 10.26, and then 30 sine of 70 will give you 28.19. Is that what you guys got? Okay, so then to find the work, you're doing the dot product of your force and your distance. Okay, so this is going to be 200, 0, and 10.26 times 28.19. Now, when you multiply anything by 0, you know you're just going to get 0. So don't bother multiplying that part. And then 200 times 10.26 actually turns out very nicely. Okay, now the unit for this work is the distance and the force. So the distance is measured in feet, the force is measured in pounds. So this is called foot-pounds, which I know is really strange. Okay, but it's telling you the force in terms of feet and pounds. Okay, so 2,052. Okay, so again, the way that you calculate your unit is the distance and then the unit for your force. Okay, so I'm going to give you your homework. And then after you write down your homework, I need you to silently clear your desk. All you need is a correcting utensil and a calculator. Okay, and then I will start passing out your tests so we can go over them.